All right, so today we're going to look at 3.6, which is on transformations of functions. So the idea, we're going to talk about basically how you can take a graph and move it. Right? Different ways we can take a graph and move it. We can move it up, move it down, move it left, move it right. And we could also take a graph, like let's say we had something that looked like a circle. Okay, we're not going to do one as complicated as a circle, but doing something like that, that's an example of a stretch. So we can stretch graphs. We can also compress graphs. Different things like that. So that's what we're going to look at. How we can stretch and compress graphs, or how we can just take a graph and shift it. Left, right, up and down. So that shifting left, right, up and down, that is called a translation. Okay? You can also just say the word shift. So on your guided notes where it says a blank is a transformation that shifts the graph horizontally or vertically, but does not change the size, shape, or orientation, that is called a translation. So a translation literally just takes an object and it just moves it somewhere else. It can't stretch it out. That's something different. All right, so let's say you had that line. And I said to you, I want you to shift it right, 1 unit. Well, let me make a copy of it so you can kind of see it. Make it a different color. Let's do, that's good. All right, so if you took that graph and you shifted it right 1 unit, it might look like that. That's an example of a translation. Now, the other one that I showed you, or I didn't show you this one yet, a reflection. So a reflection is like a mirror image of a graph. Okay, I'll do it with a letter in the alphabet so you can kind of see what a reflection looks like. So a reflection is like a flip or a mirror image. All right, let's say you had the letter B. Okay. And let's imagine that that dotted line is what we're going to flip it over. So think of it like this B, if it was like wet paint, and you folded a piece of paper on that line, and you pressed it down. You'd have a mirror image of it on the other side. And it would look something like this. That's what it would look like if you folded it right on that line. That's called a reflection. So that's a reflection, flipping it left to right. We could also do a reflection like, let's say we had a triangle, and you folded it over that line. It would look more like this. So those are both examples of what we call reflections. Okay, any question on that idea? Okay, these are not translations, the B and the triangle. All you can do with a translation is take this and drag it somewhere else. If you drag this somewhere else, just like I'm doing now, would it ever look like the one on the right? If you just take this and move it like that? No. It can't look like the one on the right because it's a mirror image. Okay, same with this triangle. No matter how you drag it, it's never going to look like the one on the bottom, because it's not a translation. Okay. Any question on those two? Reflection and translation. All right. The next thing we're going to do is we're going to make a table. So we're going to eventually do a problem like this. We're going to be given something, and they're going to put a number. They're going to put a number on the end. Or maybe they'll put the number inside the parentheses. Well, this +3 is going to do something to the graph. Maybe it's going to move it somehow. Maybe it's going to move it up 3. Maybe it moves it left 3, down 3, or right 3. We have to figure out what the +3 is going to do. It does something different here than it does here. And the reason it does something different is because of where the +3 is. Here it's outside the parentheses. On the bottom one, it's inside. Okay, so it makes a difference where we put it. So I'm going to make a chart. I'm going to give you guys a chart that shows you exactly what happens, okay, in each case. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8 different things that can happen, and we'll go through each one right now. Okay, do I want to do that? Okay, so yeah, we can write this down first, and then we'll do the table. So if we want to figure out where a new graph is going to be, we can't do it unless we know where it started. Like if I said to you, I want you to shift the point right 3 units. Well, what point? You need to know what point you're shifting. So you have to start with a table for your original graph. And then once you know those points, you can move them left, right, up, or down. But if you don't know where you're starting from, you can't do that. Right, and we'll go through an example of how to do that. All right, so now the next 8 things are all going to be written in the table. Okay. Each transformation we're going to talk about has 4 things we're going to write down. The left column where it says problem written like, that's where you're going to write down something kind of like this. What does it look like when you see the problem written out on paper? Okay. The next column, type of transformation, that's going to be words, like vertical shift up 3. So it's going to kind of explain what the +3 means. Right. And then we'll do the other 2 columns as well. All right, so let's start with the first one. So on the first row where it says problem written like, you want to put down what's in that box. Number, and then in parentheses, f of x. Okay, so that goes in the first column. And when we do an actual problem, you won't see the word number, you'll see a number, like this. Anytime that you see a number in front of that f of x, that type of transformation is called a vertical stretch. What a vertical stretch does is it takes a picture that looks like that, and it makes it look more like that. It stretches it out. So would that be a translation to take something like that and turn it into that? What do you think, right? No. That's not a transformation. A translation just takes and moves it. Can't stretch it. Okay, so this is not a translation. It's a stretch. It stretches it out. So how would you actually graph that? Okay, whenever you're doing a vertical stretch, you have to take and multiply the y values by a number. So in the how to graph column, put down multiply y values by a number. And the last thing, how do you describe it? That's the sentence you use when you want to describe a vertical stretch. So if I was going to describe this problem to somebody that couldn't see what was written down, I would say, okay, my problem says vertical stretch by a factor of 4. And if I say that, somebody who knows what that means should be able to figure out what's in that red box. So if I said, all right, I'm thinking of a problem that's a vertical stretch by a factor of 2. Okay, somebody that knows what that means would know I mean this. That's a vertical stretch by a factor of 2. Any question on that first one? So just to be clear, like where that number's coming from, the number that's in front right there is the same number that you put right there. And it's the same number that you're using right there. So, just depends on what the number is. All right, so that's the first one. We're going to go through, we're going to do all the vertical first, and then we'll do all the horizontal one second. Okay. Now, look at, we'll just call this one box 2. Look at box 2 and compare it to box 1. What's the difference where the number is this time? Look at the number in the box. What's the difference between where it is? Yeah?
Oh, it's like at the end.
Yeah, this time it's at the end. And what are you doing with the number? Like up top, we were multiplying.
You're adding it.
By the number. We're adding the number. That's different. Okay, if you add the number at the end, which actually is very similar to one of the first ones we're going to do. If you add the number at the end, that's called a vertical shift. Specifically up. Okay, so adding a number at the end shifts your graph up. So if you're actually doing that with coordinates, how do you take a graph and you shift it up? You have to make all the y values bigger. You got to make all the y values higher. That's how you shift something up. What do you think you would do to the y values if you wanted to shift something down? Yeah, you'd make the y values smaller. Yeah, you'd subtract. So we'll do that one. I think we'll do that one next. Right? And the way you would describe it is you say shift up, and then you say the number of units. So again, this number that you're using here is that number there and that number there. All right, so let's say I was thinking of a graph that was shifted up 5 units. I would write this. Putting a +5 on the end means to take whatever graph you started with. Okay, think of that as like the original. And then you did a +5. It would shift it up 5. Okay, so any questions on what you put in the second row? Okay, I tried to label each thing. The written type of transformation, how to graph, and then how to describe. All right, let's do the third one. So the third one, very similar to the second one. What's the only difference between what's in the second box and what's in the third box?
Subtraction.
It's subtraction. So you still have a number that's on the outside. The difference is when you put a minus, it would take your graph and it would translate it down. Right? So this type of transformation, when you see minus a number at the end, is called a vertical shift down. And you can use this chart on the test. I'd say this would probably be the most handy thing to have to take the test, yeah.
And there's the number.
Yep, just sign out for me. Okay, so how do you actually shift something down? You have to take all the y values and make them smaller. So we do a problem. We're going to take whatever number we have right there, and we're going to subtract that number from all the y values. I think what we'll do is I'm going to finish the horizontal transformations, and then I'm going to skip the rest of the table on the front for now, and then we'll do a problem. Right? And then we'll come back and we'll fill in the last 4 rows. I want to try an example. Okay, and how do you describe that one? You would say shift down. And you don't say the word number, you fill in the number. So let's say we had something like this. F of x minus 3. Okay. So the first thing I would do is I would say, okay, I have a problem and it has a -3 on the end. So I look at all my boxes and say, all right, is it times a number in front? No. Is it plus a number at the end? No. Is it minus a number at the end? Yes. So then I'd say, okay, that's going to do a shift down, and it's going to shift down. Now I look at my number. 3. It's going to shift down 3 units. So that's how you use this chart. You look at your problem, and you try to match it to what's in the box. And then it tells you what to do from there. But you got to match it to a box first. All right, and the last one. The last one is when there is a negative, just a negative in front of the f of x. Okay, what a negative does is it causes the graph to flip. Okay, that's how we know we have a flip. So negative symbols cause flips. I'll show you an example. I'm going to do it on the calculator. Okay, so there's a graph. And now I'm going to take that same graph and I'm just going to put a negative in front of it. And I want you to watch what happens. Okay, what does it say that the negative should do? It should cause the graph to reflect. Yeah, it should cause the graph to reflect. Right, so if you can't see what I did, I just typed in something, and then I typed in something else with a negative in front of it. Okay, let's see what the negative does to it. So here's the original, and here's the one with the negative in front of it. Okay. People see how it reflected? It's like if you folded it right on that black line, it would land right on top of the red one. That's what a negative does, causes the graph to flip over. So how do you actually make something flip, okay, when you're doing coordinates? You take all the y values and you make them the opposite. That's how you make something flip. Take all the y values and make them the opposite. So let's look at an example, right? Just kind of a estimate right there. Let's say that that point is 2, 3. Okay? Just estimating. If this is a reflection, then the point 2, -3 should be on the graph. I should be able to take the y value, make it the opposite, and let's say 2, 1, 2, 3. Yeah, right there. 2, -3. That's how you find the new points when you do a flip. Make all the y values the opposite. And again, the point here isn't to memorize. You don't have to memorize any of it. You just have to know what you're looking for, and you can use that on the test. Okay, and then how do you describe it? Well, the way you describe it is basically the same as the type. You just say a reflection over the x-axis. Okay, so that's all the vertical stuff. So I'm going to go to an example now in the notes, and let's try one and see what we can do. Okay, does everybody have the front filled in just up to that 4th row? Okay. All right, let's flip over. And let's look at example 1. 1A. We can't do 1B yet because I haven't shown you that one. Well, I think we can do 1A. So it says, here's our original graph, and this is describing what they want us to do to it. Let's just see if we can figure out what that means first. They're telling us to do a +3, and it's on the end. So let's go back to our table and see if we have one that says plus a number, okay, on the end. Let's go back. Let's go like that. So do you see either box 1, 2, 3, or 4? Which one looks kind of like the problem that we're going to do? 2. Yeah. Let me move this so we can see it. Yeah, that's box 2. Any question on why it's box 2? So box 2 has the plus the number. It's not minus a number. There's no negative symbol in the front. It's not times a number in the front. It's plus a number at the end. So when we plus a number at the end, what kind of transformation is that? How do we like know what it's going to do? Yeah.
It's gonna be a vertical shift up.
Yep. It's going to be a vertical shift up. So what I'm going to do is I'm just going to label that so I don't forget what it is. So this is a vertical shift up. And how many units up is it going to go?
3.
Yeah, it's going to go up 3. It's going to go up 3 because 3 is the number at the end. And it's going to be shifting up because it's plus a number. And that's what the table said it does. All right, so what we want to do now is they want us to graph the new one. Okay, they want us to graph the new one. I'll graph the original one and the new one so you can kind of see both. And one of them should be above the other because it went up 3. Let's pick 3 coordinates to graph the original. Now you can pick any numbers that you want for x. You're basically going to pick 3 numbers for x and you're going to fill them in. I would pick easy numbers to work with. What do you think an easy x value would be that I could plug into this formula? Right there.
2.
Yeah, 2's a good one. All right, and we're going to plug that in. We'll do that in a second. What's another x value I could pick?
1.
Okay, we could do 1. And what's one more x value I could pick?
0.
Yeah, we could do 0, sure. Now, I could just tell you, always pick this number, and this number. But I want you to be able to pick the x values that work for you. You can't do it wrong. You can pick any x value you want. The only thing that can happen is if you pick an x value that's too big, you might go off your graph. If I picked 50, what's 2 times 50?
100.
And what's 100 minus 1?
99.
99. Does it look like my graph goes up to 99? No. So there's nothing wrong with the number 50. It's just that it goes off my graph and I don't have enough space to use it. So if that happens, pick a smaller number. Okay. All right, so now let's plug them in. We were doing 2, 1, and 0. If we plug in 2, what's 2 times 2?
4.
4 minus 1. 3. That's going to be one of the original coordinates on my graph. 2, 3. Right, let's plug in 1. What's 2 times 1?
2.
2. Take away 1.
1.
1. That's going to be another coordinate. And technically, if I want to draw a line, how many coordinates do I need? At a minimum.
2.
I only need 2. The third one is just like to double check that we did it okay. So let's plug in 0. What's 2 times 0? 0 minus 1. Negative 1. If we did this right, all 3 of those points should be in a straight line. If they're not, then we made a mistake. All right, let's check. How do I graph the point 2, 3? Starting at the origin, which way do I go? Yeah. How do we graph the point 2, 3?
You would go to the right 2 times and up 3.
Up 3. There's 1. How do we graph the point 1, 1?
You go to the right ones, up 1.
Right 1, up 1. And how about the point 0, negative 1?
Just 1 down.
Just 1 down. Does it look like those points are in a straight line?
Yes.
Yep. All right. So let's do, I guess I'll make this line red. All right, so let's make that red. I'm a little bit off, but that's okay. And I'm going to label that the original. Okay, those are the original coordinates. Now we have to do a transformation to that red one. What did we say the transformation is in this one? What is the problem telling us to do to that line?
Vertical shift up.
Vertical shift up 3. So let's go back and look at our table and see what it says to do to these coordinates to move them up 3. Okay. So under the how to graph, what does it say to do to move your graph up 3? Oh, Pam?
Why the Y value? No.
No, we're doing box 2.
Oh, sorry.
We're doing box 2.
Add the number to all the Y values.
Add the number to all the y values. Well, first of all, what are the y values here? The first column or the second column? Second. So we're going to add the number to all the y values. Well, what's the number? What is it?
3.
Yeah, 3. We're adding 3 to all the y values. That's the number. Right? Because it says plus 3. So if we're going to change the y values, the x's don't change. That's going to be a 2, a 1, and a 0. Now we're going to add 3 to all the y values, and that should shift it up 3. What's 3 plus 3? 6. What's 1 plus 3? 4. And negative 1 plus 3? 2. So now we added 3 to all the y values. Let's graph those points and see how it looks. So we've got 2.
Do we need to graph them?
What's that?
Do we need to graph them?
Yes. Yep. So we have 2, 6. We have the point 1, 1, 2, 3, 4. And we've got the point 0, 2. All right, let's draw that line. Okay, like that. And let's see, I'll just leave that one black. And that is the new one. Does it look like the black one went up 3 units?
Yes.
Yeah. If you count each dot, this one went up 1, 2, 3. This one went up 1, 2, 3. And that one went up 1, 2, 3. And that's basically that's what we're doing here. Any question on that one? Now, adding a number inside the parentheses. Do we have one in our table that looks like that yet? Look at the 4 boxes. Is there one that has plus a number and it's inside the parentheses? What do you think? No, not yet. We haven't done plus a number inside. So I'm going to show you the other transformations, which are all the horizontals. Okay, these are all the verticals. Let me see if there is one more vertical I had first. It's a horizontal. Okay, actually we could do this one, just because it ties in with what we already did. Let's go to example 2. Skip 1b. We haven't done 1b yet. Let's try example 2. So they give us an equation. Do you guys already have the equation 1/2 x plus 1? Okay, you got that. So now they want us to do what we just did before. Graph the original. And the one that's right here, that means the new one. All right. So this is what they're telling you to do. Just look at this. What's inside that box? Is it plus a number at the end? Is it minus a number at the end? You Can you say a little more? Like, let's match it up with one of these boxes. Which one of those does it look like? 1, 2, 3, or 4?
4.
Yeah, so that's 4. That's box 4. It's where you have a negative symbol in the front. What did we say that a negative symbol is in the front does? How would you describe that?
Wait, what was it?
How would you describe when we have a negative symbol in the front?
Reflection over x-axis.
Yeah, exactly. So we just look up the box, and then it tells us everything we need to know. Okay. The important thing we need to know is this second one. We're going to need that in a little bit. So we're going to describe this as reflect over the x-axis. Okay, so let's write that down. So this is a reflect over the x-axis. All right, so first thing we want to do is we want to pick 3 coordinates to start with, and then we're going to figure out what we have to do to get the new ones.
Did you see example D, example B?
Yes. Yep, we're going to come back to 1B because I haven't given you the table for that yet. All right. What would be some good x values that we could plug in this formula? Preferably, I'd like to plug in x values that don't give me fractions.
1.
You could do 1, but 1's going to give you a fraction if you plug it in for x.
What kind?
Well, if you plug in 0.5, that's also going to give you a fraction. What kind of number can you take half of and you do not get a fraction?
10.
10, yeah, 10 would be 1. So you could do 10.
4.
You could do 4.
2.
And 2. Even numbers. Yeah, I would pick even numbers because you need a number that you can take half of. I mean, you can take half of an odd number if you want to. You're just going to have to deal with fractions. All right, so let's plug in 10. What's half of 10?
5.
And then plus 1?
6.
6. Okay. Molly, what's half of 4?
2.
And then plus 1?
Oh wait, no, 3, sorry.
3. And then now 2. What's half of 2? Yeah.
1.
1, and then plus 1.
2.
2. So here are the points on the original graph. Are they the only points you could pick? Definitely not. You could pick any points you want, but don't go too big and try to pick ones that aren't fractions. All right, so we've got 10, 6. Just barely on the graph, but we got enough room to get it. Hopefully your graph goes to 10. I think it does. 4, 3. So 1, 2, 3, 4. 1, 2, 3. And 2, 2. 2, 2. Does it look like those points are in a straight line?
Yeah.
Yeah. Oh, looks good. So that's going to be the original. All right, now we need the new coordinates. Let's go back to our table and look at the how to graph column. Look at the how to graph column when there's a negative in the front like that. Okay, so which box are we looking at again? For boxes 1 through 4? Box 4. And what does it say to do under the how to graph column? That's the how to describe it, yes. So it is, and I think that's the next part of the question actually, describe. So we are going to write that down, but we need the how to graph part.
Make all y values of the opposite sign.
Make all y values the opposite sign. So let's look at the problem. Which ones are the y values here? Which numbers? Yeah?
The 6, 3, and 2.
Yep. So the 10 and the 4 and the 2, those aren't changing. Now we have to make all y values the opposite. Okay. So what's the opposite of 6?
3. -6.
-6. And the opposite of 3? And the opposite of 2. Okay. By making all the y values the opposite, you should have just done a reflection over the x-axis. All right, let's try it. Okay, how do I graph 10, -6?
Up 10, and then to the left.
Right 10.
Right 10, sorry, right
Yep.
10, and down 6.
Yep, and then down 1, 2, 3, 4, 5, 6. All right, how about 4, -3?
4, -3, 4 to the right, and then 3 down.
All right, so 4 to the right, 1, 2, 3, 4, and 3 down. Perfect. And how about 2, -2?
So it'd be 2 to the right, 2 down.
2 to the right, 2 down. Okay. Now, if you look at the black dots and look at the red dots, if you were to fold that piece of paper, those black dots would land exactly on top of those red dots. Perfect. So that, let me see if I can draw that a little better. In red, that is a reflection of the graph in black. Right, any question on that? Now, the last part says describe the transformation. Well, we already did that up above. I can just write the answer again. How did we describe the transformation here? Reflect over. Yeah, I already wrote it down. I just didn't write it in the right spot. So reflect over x-axis. So if you have that table, it's really not that bad. You just have to look it up and see what box does it match up with. And then the row in the table tells you everything to do. All right, could we do this one? No, we have not talked about that yet. Yeah. Yeah. Yeah, just sign up. Okay, so I gave you guys rows 1, 2, 3, and 4. So now, I'm going to start with row 5. The first 4 that we did all have the word vertical in them. These are all going to have the word horizontal. Okay, so the 5 is there. That's row 5 in your table. Okay, what does this kind of transformation look like? Well, it's kind of like the one that we did before. It's times a number. But notice, where is the number in box 5 compared to where it was in box 1? What's the difference?
The numbers getting multiplied.
So where is the number?
And like, oh, in the middle.
It's right, it's in the middle, it's inside the parentheses. So it's the difference between doing something like this and doing something like this. Big difference. The 2 is out in front or the 2 is inside. If the number is inside, that's called a horizontal stretch. That's how you describe it. So how do you do a horizontal stretch? Well, anything horizontal is going to change the x values. Okay, on the last couple problems we did, we changed the y's. And we changed the y's again. These are all going to change the x's. So if you have a problem that matches the pattern in box 5, this is what you want to put in the how to graph. Divide the x values by the number. And divide x values by the number. What number? Well, whatever number is in front of x. So could this mean we get some fractions? Yep. Could mean we get some fractions. So preferably, I'm going to try to pick numbers that avoid that. And usually you can, if you pick numbers correctly. All right, so how do you describe it? Okay, this is probably the trickiest one to describe, but again, as long as you write this sentence, all you have to do is fill in the word number. This is a horizontal stretch by a factor of 1 divided by our number. So if the number was a 2, we would say horizontal stretch by factor of a half.
It's box number 5, right?
What's that?
It's box number 5.
That's row 5, yep. Okay, so the most important thing is that you get what's in the black box, because that's how you match up your problem to your table. Once you match that up, everything else tells you what to do. If they ask you to describe the problem, you use the how to describe it. If they ask you to graph it, you use the how to graph it. If they ask you what type of transformation it is, you use the type of transformation column. So you just have to look at what they want to know. All right, let's look at boxes 2 and 3. Both boxes 2 and 3 had either adding a number or subtracting a number. Where was the number in boxes 2 and 3? At the end. Well, now, we're going to add and we're going to subtract the number, but it's going to be inside. That's the key with everything horizontal. The number is inside the parentheses. With everything vertical, the number was on the outside. Okay, that's the difference. So if you have a problem that's x plus a number, okay. Actually, let me keep that there. Move that. In this one in red that I'm pointing to, is the number inside or outside the parentheses?
Outside.
Outside. How about now?
Inside.
Inside. That's the difference between box 6 and box 2. One has the number outside, one has the number inside. Okay, so how do you graph something like that? Well, if something is going to move left, that means it's moving towards the negative numbers. So you need to make all the x values smaller. So under how to graph for box 6, you're going to put box 6. Yeah. So under, oh, you copied some of the other ones you missed? I gotcha. So subtract number from all the x values. Okay, and what's the number? Well, we don't know. That would be given to us in the problem. In this kind of problem, it would be a 5. So that number is that number. And the way that you describe it, if they ask for that, is shift left, number of units. Now boxes 2 and 3, those were pretty similar. The only differences was plus a number and minus a number. Boxes 6 and 7 are also pretty similar. So anybody have a guess what they think I'm going to write down for box 7?
Reflective of the y-axis.
That's going to be box 8. That'll be the very last one we do. But yes, we are going to do reflect over the y-axis.
Alright.
But how about for box 7? It's going to be similar to like box 2 and 3. So box 6 had x plus a number. Box 7 is going to be x minus a number. Yeah. What's the difference between box 7 and box 3? They both look the same to me. They both have they both have minus a number.
The number's inside.
Right. Everything that I'm doing in green on the right, the number is always inside. Everything that we did in yellow on the left, it was outside. Yep. So the type of transformation, when you do x minus a number, that's going to shift right. How do you think I'm going to graph it? What do you think is going to go in the how to graph based on the one that we just did in box 6? So shift left, we subtracted a number from the x values. What do you think is going to happen for a shift right? So what do you think I'm going to put down under how to graph?
So add number
Yeah.
from places.
Yep. So it's just the opposite of box 6. Add a number to all the y values. And if they ask how do you describe it, you basically just say you shift right. And then however many units you shifted right. Okay, so this is really just about recognizing a pattern. You have to recognize the pattern of one of the 8 boxes. Well, I haven't given you the 8th box yet, but I think some of you already kind of figured out what it's going to be. So box 4 was reflect over the x-axis. What did you think box 8 was going to be? It's similar.
Reflect over y-axis.
Yes, that's going to be a reflect over the y-axis. And what symbol did we have in box 4 that told us we were doing a reflection?
Negative.
We had a negative. Yep,
So
we had a negative.
negative, you just put in positive.
No, it's still going to be a negative. Negatives always tell you to do reflections. But where was the negative in box 4?
DF, so it'd be on the X, I guess.
Yeah. The negative was on the outside of the parentheses. So where do you think the negative is going to be in box 8?
Inside.
Inside, exactly. The negative is on the inside. So it's a lot of stuff to remember, but that's why you don't have to memorize it. I just want you to use this chart. So if you don't have the chart, then, well, it's kind of hard to do. Okay, so that is box 8. When you have a negative, when you see the negative like that, it's a reflection, then you just have to look where it is. Is it inside the parentheses? Or is it in front? If it's inside, that's a horizontal reflection. Okay, when we did a reflection before, we had to make all the y values the opposite. Well, now we have to make all the x values the opposite. And the last thing is the how to describe it. What do you think I'm going to write under how to describe it, based on what we had in box 4?
Reflect over y-axis.
Reflect over y-axis. Exactly. So now we'll try a couple of those problems that we skipped because I hadn't given you the ones on the right. So we're going to there's still one thing to write at the bottom. We'll do those 1 through 6 in a minute. But I want to go to example 1B first. Anything that anyone still needs to copy down? Let's look at example 1B. Okay, so 1B, let me just erase this. They're giving you this. It says F, and then they have a +3 inside the parentheses. So let's go back to our table and match up adding a number inside the parentheses. This.
I'm number 6.
That is definitely box 6. So now for this entire problem, the only thing you need to focus on is what I just circled. Those are the directions to do what they want you to do. So that is box 6. Okay, so that's really the hardest part, just matching that up. All right, now let's write down, describe the transformation. Okay, well, let's do that right here. When you have in box 6, what does it say under the describe the transformation column? Because that's what they want you to do right here. Yeah, you think you know? What does it say to do? We're using box 6, and I need to know what does it say to do for the describe the transformation in box 6. I mean, technically, it says how to describe it. But what's in that column?
Graph F to the graph G and T.
Yeah. Just read to me the how to describe it.
You would translate it.
So go to row 6 on your table. And then under how to describe it, what does it say?
Row 6. Shift left numbers.
Shift left, and then how many left in this case?
3 times?
Yeah, shift left. 3 units. That's the how to describe it. And now we need the original coordinates. All right, let's pick any 3 numbers you want for x. Keep in mind what you need to do. You need to add 3 to them. So that's not going to make it that big. But let's pick 3 x values. Zach, can you give me 1 x value?
It would be 2.
Sure. 2. Someone give me another x value?
Yeah, 4.
You could do 4. And another x value. 6. Sure. Now it says to okay, we're using the same one again. So we're going to plug them back into the original problem, the 2x minus 1. So let's plug in 2. What's 2 times 2?
3.
Minus 1? 2 times 2 is 4 minus 1.
Yeah, 3.
That gives me 3. So we actually already had that coordinate up above. So we could have even used the same ones again, but that's fine. Let's plug in 4. What's 2 times 4?
8.
8 minus 1?
7.
7. And the last one was 6. What's 2 times 6?
12.
12 minus 1? 11. So it goes slightly off the graph. We'll have to deal with that, but that's okay. All right. So those are our originals. And we already, you know what? I'll just make a new grad for that. Or do you guys have 2 graphs?
Nope, we only have 1.
We only have 1. All right, so I'm going to do it the same way you guys have it. All right. So first one we did was the plus 3 on the end. Now we're going to do the plus 3 on the inside. So how do we get the new coordinates? What does it say to do under row 6? On the how to graph.
Subtract the number from
Subtract the number from the
the x's.
x's. So the x's are 2, 4, and 6. And what number are we going to subtract from all of them? 3. Yep. And I'm going to graph it on the same graph I did the other problem. So what's 2 minus 3?
-1.
And 4 minus 3, Sam?
1.
1. And 6 minus 3, how about Molly? 3. So we subtracted 3 from all the x's, and the y's stay the same. So part A, that's why I use different colors. Part A is the black line. Part B, I'm going to do as the green line. And red, well, that was the red was the original problem. All right, so let's graph the new coordinates for part B. So we have -1, 3. -1, 1, 2, 3. We have 1, 7. So 1, 1, 2, 3, 4, 5, 6, 7. And then we have 3 and 11. So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just one off the grid, so that's not that bad. All right, and what happened in that one? The red line shifted left 3 units. And I want that to be green. Okay, I'm going to try to make sure you have your own grid for each problem. But the black one, that was the shifting up 3, and the green one was the shifting left 3. Right, any question why the plus 3 moved it left 3? All right, try another one of those. Let's do example 3, which has its own grid. All right, let me see. Let's try it. Okay, so it says let f of x equal x minus 1, and this is the transformation that we're doing. So there's a number in front of the x. Let's go back to our table. And which row has a number in front of an x? Or which box?
5.
Yep, this problem is going to be box 5. So everything else here we're going to ignore. The only thing you need to look at is what I just circled in red. Any question why it's box 5? That's the only one that has the number in front of the x. Okay. And what is our number that's in front of x in this case?
1/3.
Yep, it's going to be 1/3. All right, so let's get some original coordinates, and then we'll get the new coordinate, and then we'll describe the transformation. All right. What would be a good x value that we could pick? And keep in mind, you have to take 1/3 of it. So I'd like to avoid fractions if we could.
6.
6 is perfect. Yep. What's another good number we could take 1/3 of?
9.
9. That would be a good one. And what's another number?
12.
Yeah, we could do 12. It might go off the graph a little bit. Can we think of a number that's smaller? Yeah? 3. That's a good one. All right, let's let's plug it in. Okay, plug in 6. What's 6 minus 1? 5. What's 9 minus 1? 8. And what's 3 minus 1? 2. Okay, so there's our original line. So let's graph that. So 6, 6, 5, 9, 2, 3, 4, 5, 6, 7, 8, and 3, 2. Okay, do those look like they're in a straight line?
Yes.
Yeah. Good to me. All right, so let's draw the line. Okay, and I'll label that in black. That's the original. Now we're going to do the new one. So go back to the row that has the number in front of X. We have to look at the how to graph column. Okay, so that's row 5. What does it say to do under the how to graph?
Divide x values by what's the number? 1?
Yep, divide the x values by the number. Okay. All right. Well, we picked numbers that were a little too big, but that's fine. So where are the? Which ones are the x values here?
6, 9, and 3.
Yep. And we're going to take all those x values and divide them by what number?
3, 1/3.
1/3. That's the number that's in front of x. Okay. So the 5, the 8, and the 2, those stay exactly the same. Right. And we're going to use our calculator because we're going to have a fraction to deal with. Okay, what are we dividing each number by?
3 or 1/3.
1/3. Yeah. So we're going to take 6, and I'm just going to type in divided by 1/3, and we get 18. Okay. What are we going to divide 9 by? Divided by 1/3 gives me 27. And what are we going to divide the 3 by?
1/3.
1/3. Yep. That's actually the only one that would fit on the graph. Can add in one more point. If I put in 0, what's 0 minus 1? -1. And if we take 0, let's divide that by 1/3. I'm just doing a 4th point because the 3 that I did, the other 2 got too big. 0. So that point stayed the same. Which 2 in that table are ones that I could graph?
9.
9 and 2.
Yeah.
And 0 and 4.
Good enough. I can just graph those 2. All right. And we'll do the new. I'll do the new one in blue. So we got 9, 2. 9, 2. And the point 0, -1. Okay, I know it's only 2 points, but that's kind of the best I can do this time. Make that blue. And that's the new one. So blue is the new, and black is the original. If you find that when you did your points, they come out too big, you can always just do another one like I did and pick a smaller number if you picked ones that were too big. There's nothing wrong with these other coordinates. We did them right. I don't have enough space. Question on that? All right, so we did example 1A, 1B, we did 2A, I think we did 3. All right, let me give you the last note thing, and then we might do example 4 tomorrow. So did I give you the 1 through 6 on the front yet? Okay. So the 1 through 6, that's actually a little easier because you don't have to graph anything. All you have to do is describe. So we had problems like this, or something like f of x plus 3. And the way we described it is we said shift up 3. Okay. I think we had something, maybe like that. And the way we described that one was shift right 2. Well, what if you have a problem like this? There's 2 things happening. There's a minus 2, and there's a plus 3. Which one do you say first? Do you say shift up 3, and then say shift right 2? Or do you say shift right 2, and then up 3? There is a certain order you do have to say it in. And yeah, you would describe the horizontal shift first, and you would describe the vertical shift after. That's the order that we always describe transformations.
So we just write row to 3.
Yeah, as long as you know that order. Okay. So anytime that we have to describe multiple transformations in a problem, that's the order that they need to be described.
So for one, it would be horizontal shift.
1 is horizontal shift. Yep. If your problem has a horizontal shift, we write it down. If it doesn't, we go to number 2. So that's the order that we have to follow to describe transformations. So I think the last question on the homework is describing the transformation. If you get stuck on like the last question or 2, that's okay. We'll do the last question or 2 in the warm-up tomorrow.
Wait, what's the homework?
The homework is the 3.6 worksheet. And if you get stuck on the one that says to describe all the transformations in order, we're going to do that as a warm-up tomorrow.
What's